Hi, in this tutorial, we will learn about power rules. What is power rule? Power rule is used whenever we see a function with a bracket and a plus minus sign in that bracket and the power is n. N can be a fraction, it can be a negative number, it can also be a positive number. It's similar to the function that we see whenever we use chain rule. So, whenever you see this form, you can use either chain rule or you can also use power rule. Power rule is easier. Why do I say power rule is easier? Because it's similar to like the basic concept of differentiation. For example, you have u to the power of n. The concept of power rule is when you want to differentiate this function y, you just bring the power to the front and then copy down the function u. Next, just subtract 1 with the power. But what you have to do next is just you have to differentiate the function u. We can also say this as when y is equal to a function of fx and it has power n, what you have to do next is just to bring the power to the front when you differentiate, copy down the function. After that, just subtract 1 with the power and then multiply with the derivative of the function f, written as f prime x. Remember, f prime x simply means the derivative of fx. Let's look at a few examples on how to apply this formula. Look at example 1a. We have a function y and then it has a power 8. The function is in a big bracket. Remember, when you have power 8, that means we have this bracket with the same function but 8 times. 8 brackets. Are you going to expand those brackets one by one? Well, it's very tedious and takes a lot of time. So the easiest way is for you to use chain rule or power rule to differentiate this faster and easier. But since the question wants you to find the derivative by using power rule, so I have to use power rule for this question. In fact, power rule is faster and easier. If the question does not mention that you have to use by using power rule, then you can use chain rule as well for this question. So, how to differentiate this? Write dy over dx. When you write dy over dx, that means this whole line must be the derivative. Now, start by bringing down the power. The power is 8, so bring 8 down. After that, just copy down your function. And then, subtract 1 with the power. After that, you have to differentiate whatever is in the bracket. So write down your function with a d over dx in front. This just means you have to differentiate the functions in this bracket. So write the functions in this bracket here. Now, in this first line, this first term simply means we have differentiated it. But the second term behind here means that we have not differentiated. So we have to differentiate this function in the bracket first. After that, we can combine it with the function in the front. So what you can do is you can bring the terms in front first and then differentiating this green function. For x squared, when you differentiate, bring 2 to the front. 4 times 2 is 8. X, 2 minus 1 is x power 1. And then differentiate 3x. X is just power 1. So what's left is just 3. 5 is just a constant. When you differentiate constant, you get 0. Notice that there is no d over dx written in front of this because we have already differentiated this green function. So we don't have to write d over dx. If we do write d over dx in front here, this just means we have to differentiate the function, the red function. But we don't have to differentiate it anymore because we have already differentiated the green function. So at this step, we have differentiated everything. Make sure your final answer is in the simplest form, which means that we cannot factorize it anymore. Can we factorize any numbers or any x or any factors out? For this question, no. Then this will be our final answer and you just have to stop there. Okay, then try out example 1b. Remember my tips. When you have a bracket power 4, at the denominator, you can bring it up and change it as power negative 4. Now you can apply the power rule. Please remember, you do not have to use quotient rule for this question because at the numerator, there is no x. There's only x at the denominator. So we only use quotient rule whenever the numerator has x and denominator has also function in the term of x. What about question example 1c? Do we need quotient rule or not? Try to figure that out. Now let me show you one more example on how to apply the power rule. Remember, start by writing down the power. After that, just copy the function. Copy the function and do not change anything inside it. And then just subtract 1 with the power. Subtract 1 with 5, you get 4. And after that, don't forget to write d over dx and differentiate the function in this bracket. Just put it there. Next, we see that we still have the d over dx term. That means we have to differentiate this. So to differentiate this, you have to bring 1 over x and bring the x on top. To bring x on top, 1 over x just simply means x power of negative 1. Remember, to differentiate, you have to change the form. Make sure your x is at the numerator or on top. Only then you can differentiate. If not, you cannot differentiate when it's at the denominator. To differentiate x, you get 1. Differentiate x power negative 1. Bring power to the front. Negative meets negative will be positive. And then subtract 1 with the power will be negative 2. And then just copy down the others in front. Can you simplify anything else? Can you factorize anything else? Well, there's nothing that you can simplify, so this will be your final answer, but you can still change the form. Copy everything else, and then x power negative 2 just simply means 1 over x power 2. So I can change that. So you can leave your answer like this, or the last one. Both are correct. Now look at example 2. This is the function y. I want to differentiate this function y. Remember the steps. First, by using power rule, you have to bring 2 to the front, and then just copy the whole function down. Next, subtract 1 with the power. 2 minus 1 is just 1. After that, write d over dx, which means we have to differentiate the function in this bracket. Just copy everything down. Next, when you see d over dx, this means you have to differentiate the term behind this, and this term is in the form of fraction. You have x at the numerator and also x at the denominator. So how to differentiate this fraction which has x at the numerator and x at the denominator? Remember, you have to use quotient rule. Quotient rule is whenever you have the terms of x at the numerator and the terms of x at the denominator. Before you differentiate, don't forget to copy down the function in front. And then put a big bracket for your quotient rule formula. Write your u and v for your quotient. U is always the numerator and v is always the denominator. Write them side by side. And then next is to differentiate your u and v. Differentiate u, what you get is 3. Differentiate v, you get is negative 1. Next, remember your crossfish sign with the I. Negative, divide with v squared. After that, write your formula, v times u prime minus u times v prime. So write down the v multiplied with the u prime minus with u function multiplied with v prime over with v squared. For quotient rule, you will always have a bracket with squared at the denominator. You don't have to expand this because the simplified form will be the form which has been factorized. So if you expand this, then it will not be in the factorized form. So leave the denominator as it is. Now just focus on the numerator. How to simplify the numerator? Is there anything that we can factorize? There's no number and there's no linear factor that we can factorize for the numerator. So what's left is to expand the numerator. Be careful, this negative is for all of the functions behind. So when this negative multiplied with negative 1, you get positive. After that, simplify. Negative 3x plus 3x. 6 plus 2 is 8. And that's your simplified fraction. Now, can you simplify any further for these answers? Find similar linear factors or any other numbers that you can factorize. As you can see, we have 2 here and we have a number 8 here. 2 is just 2 over 1. So, remember, number multiplied with number at the numerators. So what you get is 16. But this number 16 at the numerator will also be multiplied with the numerator of this green function. So just write down the function of 3x plus 2 next to 16 and divide it with the function at the denominator. 1 times 2 minus x times 2 minus x power 2. These two expressions are the same. So we can combine these two factors and write it as power 3 because this one is power 1. So when you multiply, the power have to add up. And this would be the simplified form of your answer.